All right, so we are now starting in 3.4. And the first thing that's in this section that is important is z-scores. So the problem that I chose from the homework that is similar to your homework, it's not an exact problem, is one that is looking at usual and unusual. And you know that your z-score is -2, and I have the answers in here, is -2 and 2. So we're given the z. So we need to figure out what x is. That's what we're looking for. So the first thing that we're going to do is change our formula so that it's x equals something instead of z equals something. So the first thing we'll do is we'll multiply it by your standard deviation, which is s. So z times s equals x minus the mean. And then we're going to move the mean over so that we have x by itself. So z minus s plus the mean. So we have all of our data, so all we need to do is just enter it in. So I'm going to use parentheses just so that Excel is aware, like I want to do this part first. So we have the z-score, that's -2. We're looking for the lower one first, so we're going to use the lower bound. And then we're going to multiply that, so times the standard deviation, which we have given to us. I pulled the numbers out from the problem, so you can find that the standard deviation is 11 in the problem. You can also find that the mean is 119 in the problem. So then we're going to add to that the mean. Then we can just click enter and it's 97, so that's the lower one. And then we'll do the same thing, so we're going to take our upper z-score this time. So our upper bound of the z-score times the standard deviation. Add that to the mean. And we have 141. So if our values fall outside the range of 97 or 141, then that would be considered unusual. So for example, if I took the test and my score was a 92, that would be an unusual score. So the next part of the chapter, I have copied here some data that was from the homework. And we're going to be finding percentile, we're going to be locating what value is at a specific percentile, talking about box and whisker plots with the 5-number summary and all of that. So here we go. So I'm going to rewrite the percentile equation over to the side here so that way you can see it. So it's the percentile, which I'm just going to abbreviate with the percent sign, equals the number of values less than n. So we're looking for the number of values, so I'll just label it x. Well, it's less than our x value, so let me label it different. So we'll label it just number of values that are less than x. And we're going to divide that by the total number of values there are, which will be n, and we're going to multiply it by 100. So to be able to do that, we're just going to type it in. So the number of values less than x, so this is just saying the percentile of age 23. So we want to count, so let's count here. Change this to count. Rather than me sitting and counting all of them, and I'm going to do it in parentheses just so that Excel realizes like I'm doing something specific first. And I'm going to go to the number less than 23. So since 23 is here, I'm going to go one less than that, and that's going to be how many I'm doing there, and I'm not really sure why I put it there. It should be here. Give me a second to fix it. Okay, there we go. So that would be that part, and then divided by the total there is. So we're going to count again, and we're going to take those number of values, and then we're going to highlight the entire data set. So then we'll close parentheses twice, and we're multiplying that entire thing, like our formula says, by 100. So the percentile at age 23 would be 13.8 or 0.9%. They often have you round them to 1 decimal point, sometimes 2. All right, so the next part of it says, if I have a percentile of 40, what is the value at that point? So there's a few things you need to know, but we're going to start with the formula, and I'm going to rewrite it so that way you can see it. So the location of a percentile value would be the percentiles, so I'll just write percent, divided by 100, times the number of data points, so times n. So if we start off, we're going to do equals. I'm going to just do parentheses again, just so that Excel knows I'm doing this first. Times the number of values there are, so we're going to count, and we're going to count from 17. And we're going to go all the way down. And close out the parentheses, hit enter. So 14.4. Now 14.4 obviously isn't here, but we're not looking for that value. We want to know, we know that that's the location. It's 14.4 values in. Because it's a decimal, we round up. So we're looking for the 15th value. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the percentile, the number of data, so like the data point that is at the 40th percentile is 51. So that is the answer. So 51. All right, so quartiles. Quartiles come into play with box and whisker plots. So if I draw one out for you, just as a quick reminder, we'll do that. And that can be the median. So this one is quartile 2. It's also the median. This is quartile 3, quartile 4, minimum, and maximum. Quartile 1, not 4. So quartile 1 is 25%, quartile 2 is 50%, and quartile 3 is 75%. So we're going to use the location one like we did earlier for the previous problem. And so we're going to do equals. We know that quartile 1 is 25%, so 25, keep parentheses in there, 25 divided by 100 times the number of values, so count, because I don't want to do all of them. So 9. So because it's an even value, because there's no decimal whatsoever, we have to actually take what it's at and the one above it and take the average of the two. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Make sure that's 9. All right, so 28 and 30, those are the two there. So 28 is where 9 is, and then 30 is one above it. And because it's a whole number, we have to take it and take the average. So 28 and 30. So we're just going to take the average of 28 and 30. So our answer is 29. So then quartile 3 is 75%, so 75 divided by 100. And then times the amount there is, so count will come here. And then we'll do that. And because it's an even number again, we have to find the 27th value and the 28th value and average them. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have 58 and 59. So we'll take the average of 58 and 59. Which is 58.5, so that would be our answer. So the next one is just the median. So Excel is nice, and because it's quartile 2, and because quartile 2 is the median, we can just type in median. And then we'll take the entire set of data, and we're finding the median of all of it. So that answer would be 54.5. So the next thing we have is the minimum, is the 5-number summary. We've already found quartile 1, 2, and 3, so I'm not going to really worry about those, but I'll put the answers in here so that way you can just see it. So quartile 1 is 29, quartile 2 is 54.5, and quartile 3 is 58.5. So I showed this to you previously on the Excel Basics Part 2, I believe. So you just do equals min, and then all you need to do is highlight your data set. And the nice thing is this particular data set is already set least to greatest, but sometimes they aren't, so I'm just going to go ahead and use the formula just so that you can see it being used and can kind of get used to it. And 78. So if I was to draw my box and whisker plot, which I can do, we'll use this blue. It would be, our minimum is here at 17, and then we have a little bit of a distance till we get to 29, which is quartile 1. This is the min. And then I'm just going to draw my box, not quite to data. But my median is a lot closer to my quartile 3. Because my quartile 3 is 58.5 and my median is 54.5, or quartile 2. And then my max is a fairly good distance away at 78. So your median doesn't always have to be directly in the middle of your box because you have repeated data points sometimes depending on what you're collecting. So if these were like IQ scores, multiple people can score a 61 or multiple people can score an 18, things like that. It's not just one person can get that score. So that is how 3.4 works, and I'll be posting more videos as more homework questions come.